So now that we know how to find slope, our m value, we can write equations of lines in slope-intercept form. And this is the first of 3 forms that we are going to look at. This is one of the easiest to use. It's the easiest form to use when you're going to graph an equation. We'll look at another one next time that's also really easy to use for graphing. But this is where we start just because it's the most simple form that we have. M, as we said before, represents the slope, and this constant on the end b represents the y-coordinate of the y-intercept. So if I look at my graph here, the first thing we want to do is identify the slope. So I have my 2 points, and if I'm moving between those 2 points, I have a rise of -4 and a run of 3. So my slope is going to be -4 over 3. Now I need to find the b part. So b is my y-intercept. So I look and see where my graph intersects with the y-axis, and I see that this happens right here at -2. So b equals -2. Now we just go ahead, substitute everything into our equation. So we have y equals, the only thing we replace are m and b. So we have -4/3 x plus -2. Now, we're never going to leave 2 signs next to each other like this. So we're going to reduce this and say y equals -4/3 x minus 2. And this equation represents this line. If I were to substitute this into my calculator, it would give me a picture that looks just like this. If I were to plug in x values, I would get all of the corresponding y values for the points along this line. So, go ahead, pause the video, and see if you can write the slope-intercept equations for the first 2 graphs that we have here. Alright, if we look at our graph on the left, we have between those 2 marked points a rise of 3 and a run of 6, which reduces to a slope of 1/2. Our graph cuts through the y-axis at the point 0, -1, so our b value is -1. We put it all together, we get our equation of y equals 1/2 x minus 1. If we look at the second graph, we end up with a slope of 4, and this graph actually cuts through the origin, just like our direct variation. So if we look at our equation, it looks like that direct variation equation. My y-intercept is 0, so we could write plus 0 on the end, but that's something extra that we don't need to include because plus 0 is not going to make any changes. So when we talked about the direct variation equations, they were really all in slope-intercept form, but because the y-intercept was 0, we didn't have that constant being added on at the end. Now if we look at these 2 lines, these are our special lines. On the left, we have that undefined slope, so I can't really say that y equals undefined times x plus, oh, and I don't have a y-intercept either, so that's not going to work. If we look at this one on the right, my slope is 0, so we have y equals 0x plus 1. That's going to look a little weird. So anytime we have strictly horizontal or strictly vertical lines, our equations are going to be different. If I think about all the points on this vertical line, the one thing that they all have in common is their x-coordinate. The y-coordinate changes, but the x-coordinate remains constant for every single point. In this case, the x-coordinate is 1. So because that's what they all have in common, this is the equation for this line, x equals 1. If we look at our line over here, the x-coordinates are changing, but the y-coordinate remains the same. For every single point here, the y-coordinate equals 1. So our equation would be y equals 1. There's an acronym that we can use to help us remember the information for these special slopes. And this is going to be HOY bucks. Shout out to Sophia H. for sharing this with me, since I had not seen it before. If we look at the first part, HOY. H stands for horizontal. The O stands for 0 for our slope. And the Y means that our equation is going to be y equals. If we look at the bucks part, V is for vertical, because it's a vertical line. The U is our slope of undefined. So we'll put undefined. And then X is our equations that start with x equals. So, if I wanted to graph a line, slope-intercept form is really nice because I have all the information that I need right there in front of me. If I have my slope of -2/3, this means I can use it as we go. Remember that it doesn't matter if you put the negative in the numerator or the denominator, just pick one place to use it. And then we have our y-intercept of 1, which means we're going to plot the point 0, 1. So this is where we start, because that's the first point that we know is on the graph. So we start at 1, and now I use my slope to plot the rest of the points. My numerator is my rise, so my numerator is -2, which means I go down 2, and then I run 3 points to the right. I go down 2, and since I run out of room, I don't have to plot the point down here. Then if we want to go backwards, we're going to do the opposite of what we see. So instead of -2, I do +2, and instead of 3 to the right or +3, now we go 3 to the left, or -3. I can repeat the process, but I run out of room, so that's all I have to graph. So then I connect my dots, put our arrows on the end, and our graph is complete. Go ahead, pause the video, see if you can identify the slope and the y-intercept and any other points that might be on this graph. Alright, so if we look at this equation, we have a slope of -3, which is the same thing as -3/1 or 3 over -1. I don't have a y-intercept written down, so that means that my y-intercept is 0, or the origin. So we start in the middle of our graph, we rise our -3, we run 1, then we go backwards. We rise +3 and run -1. Now the last thing that we want to be able to do is to write an equation in slope-intercept form if we're given 2 points. So here, we need to figure out our y-intercept and our slope. Luckily, we have a formula that gives us slope. So we have the difference in y's divided by the difference in x's. So I can go ahead and I can start with that. So I have my second coordinate here, so 4 minus 2 all over 0 minus -4, which is 2 over 4, or 1/2. So I have half of what I need. I need to fill in that y-intercept. If I look at my points, here I have an x-coordinate of 0. That means that this point sits on the y-axis. So that means that my y-intercept is 4. So we don't have any extra work to do. This one's nice and easy because we get our y-intercept right from the information that's given. However, if you look at the second question, you can see that we're not always going to be given that point. So sometimes, ignore the bell, we have to do a little bit of extra work. We still start in the same place. We start with our slope. So we have 2 minus -1 all over -1 minus -4. When you're working with the slope formula, it's really important to be careful with your signs because you are going to have to do some subtraction with the negative. So you just want to be careful, make sure you don't lose anything. So we have 3 over 3, which is a slope of 1. Now we need to find our y-intercept. So if I look at my equation so far, I have y equals 1x, or just x, plus b. We need to solve for this b value, which means that we need numbers that we can substitute in for y and x. If I look at my coordinates, I have 2 sets of values that I can use. I have 2 pairs of x, y coordinates. It does not matter which one you pick. I can go with the first point if I want. I'm going to take these values and substitute them into my equation, so that way I only have one unknown and I can solve for the y-intercept. So we're going to say that -1 equals -4 plus b, add 4 to both sides, and we get a y-intercept of 3. So now we can write our full equation, which is y equals x plus 3. Anytime the y-intercept is not one of your coordinate pairs, you have to take the second step of solving for b. You can't just randomly put a number in. You have to show this out that you have algebraically proved that that is your y-intercept.